but it's okay. So we have I think our audience, there are old friends here, most of them, uh, especially for those from my side, they are my students. And then I just want to welcome all of you to join DEC. Let me just briefly talk about this initiative or the colloquium. Actually, it started like 3 years ago. This is the third year. So we're glad that we're still holding on here and continue to, excuse me, and continue to invite the scholars, especially those well-known scholars or the rising star scholars like yourself. And then we try to um, just uh, just convene all the scholars, students, and who are interested in the methodology thing, especially the data science perspective. So that's why we're all here today. And I just want to thank Carl, Professor Holt, and for coordinating all those speakers here. And then he's been doing a lot of work. So I just want to personally thank him. And then, of course, this initiative or this colloquium it started with Dr. Professor Harold Clark and Chris Aiken. They're all on the board, especially, we try to, every time when we talk about this, and then we, think of Harold, and that's quite a loss here. But we still have to go on, and then still we thank him for helping us to build up this colloquium. So again, this colloquium is a collaboration between two schools. This National Chongqing University and UTD, University of Texas in Austin, to
In
Dallas.
Dallas.
Yeah, I'm sorry about that. And so basically, our audience mostly graduate students, and of course, sometimes we have our friends and colleagues from other schools too. So today, and I'm very happy to have uh, Anton here, and then let's talk about this big data and this political phenomena. So I think this is a great topic and it's very interesting to all our audiences. So I will pass this mic to Carl. So is there anything that you want to add?
Yes, thank you, Dr. Pan. Thank you, Dr. Pan. And indeed, this is a really our privilege and my pleasure to be able to coordinate this. And Dr. Pan and also a lot of colleagues in NCHU uh, have been helping us too. And some of their colleagues are also on the advisory board. And thank you for paying tribute to Harold. And he is indeed uh, playing a key role in founding this colloquium. We hope that we can continue his legacy and inviting very important scholars like Anton and Dr. Sobolev to come aboard to give us the latest in data science and research methods. Allow me to introduce Dr. Sobolev, and he's assistant professor of political economy and cyber policy at the University of Texas at Dallas. And his research studies questions of politics using text analysis, machine learning, and causal inference. And his recent projects focus on mass protest, cybersecurity, and political control in autocracies. And more broadly, he studies how digital technology shapes political and economic behavior. His work has been published in American Political Science Review, World Politics, uh, um, European Journal of Political Economy, and Post-Soviet Affairs, Europe, Asia Studies, and Problems of Post-Communism. And Dr. Sobolev received his PhD in political science and Master of Science in Statistics from the University of California, Los Angeles, UCLA. Before coming to UTD, he was a postdoctoral associate at the Leibner program in political economy at Yale University. And Dr. Sobolev has been really busy putting together our cybersecurity program. Actually, this program is the fastest, I would say, fastest and I think I don't know whether it's one of. I think it's at least it's one of the fastest growing program in UTD, and he every year has been dealing with students doubling enrollment every year, and I let him talk about his program in a little bit. And without further ado, let me introduce Dr. Sobolev for his talk titled "Using Big Data to Measure Important Political Phenomena." Anton, the floor is yours. Yeah.
Thank you, colleagues. First of all, it's a great pleasure to be here and present some of my studies and, my general vision of this field and the importance of doing proper measurements of political phenomena. Second of all, I want to apologize in advance. The version control systems are tricky, and I've just lost half of my presentation. I just probably will need to switch to a couple of my papers during the presentation itself to show you some important figures and results that have been into the presentation, but I cannot find the latest version, unfortunately. But nevertheless, I hope everything fun and probably informative for the students and other colleagues. Also, I wanted to check regarding the format of the presentation. Do people can intervene at any point or like substantive questions at the end? What are the local rules?
Mm.
Should I wait for clarification questions during the talk, or people usually ask them after?
Muted myself. Sorry, muted myself. Yeah, any way you want to, but I think in the past we could be more like informal, and students can speak up or type out questions, and maybe I can intervene and maybe interject when we have a question, and it's up to you. But if you like to entertain the questions later, yeah, it's okay too.
I think the current format of this presentation suggests that it is better if you intervene right away, even if you have a substantive question, because I will go across multiple methods, multiple issues, and probably will forget about the question you have. And the final question: how do I share the presentation? My share button is not active.
Oh, let's see. Let me see if I can change that. Somehow it has to be manually done here. Let me see. In the past, I was able. Let me see where you are now. My computer's making slow all of a sudden. Let me see if I could change to. Okay, I may need to do this. Change you to. All of a sudden, I cannot find you, and cannot find you to be on my. Yeah, let me see if on my participant list, and all of a sudden you're gone. Let me see if I can look it up. Okay, I got it now.
Can I try to request it? To request the access?
Yeah, I think now everything has to be in Teams. It has to be manually done. Yeah, can you share it now? Now I make you a presenter.
And now where is the presentation? One second, I'm sorry. Can you see the presentation now? Okay.
I see it now. Thank you. Thank you. Thank you.
Okay. Again, pleasure to be here. Feel free to interrupt me at any point. So I'm going to talk about using the big data for measuring important political phenomena. And as you already know from the abstract, I will focus on the protest behavior and how to measure, first of all, the key feature of the protest event, the protest turnout. How many people actually took to the street to show their dissatisfaction with the government policies, specific public figure, anything. But the plan, Carl, do you want me to speak up or?
No, I just asked the audience to type question or to speak a question. Please continue.
Okay, sure. We'll start. We have the following plan. So I will start with my preliminary notes on what I think about the big data and the key issues with the protest measurement. Then I talk a little bit about why it is actually crucially important, especially for the social sciences, to be able to properly and accurately measure the protest. Then I will talk about three major phases. How did the scholars of politics try to measure the protest in the early days? How they figured out that it is basically impossible to get an accurate estimates, and how they tried to switch to alternative strategies to test the theory that directly involve the protest variable, but they tried to test them without this variable using different proxies. And finally, we'll talk a little bit about the current days, right? The big data steps in. We have huge computational power, new tools, and old issues. And I'll talk a little bit about my recent and current research with a focus on how actually we propose to validate both the old and the new measures of the protest behavior, how we can go deeper and try to use the data to figure out whether a person belongs and actually participated in a specific protest and was not just a random person who happened to be on the same street. And then I'll talk a little bit about these new fruits that big data brings us, meaning that it's the first time in the history of the social sciences where, due to the availability of new machine learning methods and big data, we've been able to measure many other auxiliary features of the protest events and the protest behavior, things like the sentiments, things like the aggressiveness of the crowd, and we were unable to do it even 5 years ago, and 10 years ago we didn't have a hope to try to measure such interesting features of the protest behavior. Let's start. Okay, so the note number one: how should we think about big data? In the literature, it's a lot of the confusion with the big data. Different people call different things as big data. My example here is the big data about the, and my question here is the big data about the size of the data. So if we run a small survey, it means that we will work, like if I surveyed a class of 30 students, do I have a small data at the end? What if I do the huge cross-national survey and like world value survey, and I survey like thousands or hundreds of thousands of people, does it mean that we actually work with the big data now? So my answer is no to both situations. And I think that if we are trying to figure out what the big data is about, the big data is not about the size of the data set you work with. There are also people who believe that the big data is in fact a tidy data, the data that that is very narrow but has a very long, but is very long. I think this is not the most important part of the story. The most important part of the story for me when we talk about the big data is these two features. So first of all, big data is about specific data generating process and data collection process. The important part is that this data is generated or collected automatically. A good example of it would be the search queries on Google or Microsoft, or any search engine, right? There's millions of search requests Google process on the every second, right? And all these searches follow the same specific format. They stored in a specific place. And if you want to go and check if people were looking for specific type of events, like Nancy Pelosi decided to visit Taiwan, right? You just go to Google Trends. You check the history of the search Nancy Pelosi in Taiwan. And it shows you, the data either on the daily basis, on the weekly basis, whatever you want. You can download it and you'll have like 12 lines of data. And nevertheless, I claim that this is big data due to the underlying data generation process. Now, finally, the second feature of the big data is that big data refers to some actual behavior. It can be offline behavior, it can be online behavior, but what is important is that big data, it is something that we observe. Big data fixes, monitors observed behavior. Online or offline doesn't matter. So if we talk about the things like surveys, opinion surveys, if you collect millions, trillions, billions of opinions, it is still not a big data because opinions do not represent an actual behavior. So this, when I will talk about the other stories, that would be two major underlying assumptions I have in mind when I think about the applications of big data to social sciences. Okay, now let's talk a little bit about the fundamental issues with measuring the process. And the simplest way to realize how hard it is to study the protest is to compare the protest with the elections. On the one hand, a lot of similarities here, right? So we can think both about the protest and about elections as of a collective behavior. People go, people have the same, people share the same goals. They want a specific person to get elected, to become a president or a mayor, doesn't matter, and so on. So on the one hand, a lot of similarities. On the other hand, look at the specifics. So if we talk about some election event, forthcoming midterm elections in the US in the November, for example, what do we know? First of all, Dates and locations where you can go and vote are known in advance. Actually, most of the time, they are known years in advance, right? So if you plan to conduct an academic or commercial study of the voting behavior, you can start preparing yourself and your team years in advance. Also, from the very beginning, we know the limit for our main outcome of interest for the election turnout, right? Because we know the amount of registered voters, and the actual turnout cannot be higher than the number of registered voters on the specific polling station. Elections, in the vast majority of cases, happen inside some building. It means for an observer or for an interviewer who would like to do the exit poll, it is easy to monitor who enters and who leaves the polling station. Finally, in contrast to the protesters, voters do not need to go back and forth. They enter the polling station one time, they voted, they leave, and usually they don't go back. All these things simplifies the study of the elections, and I believe this is one of the reasons we know so much about the elections, the specific features, different mechanisms within the field of the electoral politics. Now, protest is basically absolutely opposite example of the elections. First of all, most of the time, the date of the protest is unknown. It is most of the times it's surprising for most of the people. Locations, you can have some preliminary understanding that if the protest happens somewhere in the capital city, then people try to protest around the center. They try to take the main squares and protest there. But again, it's not guaranteed. All right, the protest happens outside, right? And people can enter the protest square from the one side and leave the square from the other side, which makes it almost impossible to monitor by the observers, right? Things like maximal turnout, of course, are also unknown. And in contrast to the elections, protesters have a lot of incentives to go back and forth. First of all, protest events usually take time, hours. For example, in the cases of the Women's March that I will use in this presentation, on average, the Women March in a specific city in 2017 lasted from 3 to 5 hours. So that's a lot. And of course, during these hours, people who already participated start to leave the protest, and people who didn't participate decided to join the protest not in the first hour, but maybe after 2, 3, 4 hours. So you have this back and forth migration of the protesters to the protest square and out of the protest square. Again, that complicates the task of quantifying the protest greatly. Why it is important to study, why it is important to have a confident and accurate methods of measuring different features of the protest, especially the question of the size of the crowd who participated, who took to the street. Well, let's just take theories from all over political science. The simplest one, democratization. All models of the democratization, not only Asimov, Robinson, any models, imply that the key element for the democratization and for the readiness of the elites to provide the policy concessions and to agree with providing political reforms is a natural threat of replacement that completely depends on the ability of the unsatisfied citizens to coordinate, to mobilize themselves, and to protest together. Without proper data on the size of the protest, we cannot figure out when these theories work and when they don't. And of course, there is another, even more, a smaller strand of literature within the story about the democratization and revolutions. It's called Informational Cascades, and it was this theory was initially developed by Susan Lohman and Timur Kuran. And the question was, the idea was that actually people have very different thresholds that they use to figure out whether it's already time for them to take to the street and say no to the government, or it's not time. It's not their time. So the dynamics of these informational cascades, where on the first day 5 people took to the street, others have seen that, and people with another threshold decided, okay, we'll join them next time. And on the next day, even more people come. And we have an exponential growth in the protest participation, resulting in the revolution or in the replacement of the government. This theory basically was never tested. And the reason is we don't have a single case where we would be absolutely confident about the daily numbers reported by, say, political activists, numbers we could trust. The second story is the story about the quality of the governments and the accountability. So doesn't matter if we talk about the democratic regimes or non-democratic regimes. An important feature of, or important factor of the performance of the government is the ability of the general public to make the government accountable, meaning to ability to, to ability to react to the policy changes or the actions that they do not support, right? Several studies have shown that the ability, this ability is basically crucial for most of the indicators we use to estimate or to evaluate the quality of governments in a specific country. Because I lost this slide, I'll show you. I'll tell you here 2 of my favorite papers that study these specific questions of accountability and the quality of the governance. So one of them is the paper by Felipe Campante, and in this paper, I think it's published in 2012, and if you want, I'll just post the link to the paper later. What he's trying to do, he's trying to figure out how the indicators of the quality of the governments calculated by the World Bank correlate with the way with the specific place of where the office of the national government is located, and whether it is surrounded by the large crowd of people. Say, is it in the center of a big city, or it is somewhere else, and the biggest cities are far away from the center of the political decision making. And what Campante shows is that indeed, even if we keep everything fixed, the countries where the government lives right in front of the general public. So for general public, it is relatively easy to take to the street and tell them, we are not satisfied. Please change the policy, all probably will replace you. These types of the regimes usually show a distinctively higher level of the quality of the government services, less level of corruption, and so on. And the nicest example is, of course, the comparison of the Kuwait and Saudi Arabia. Well, the Kuwait and Saudi Arabia, from the economic perspective, are very similar countries. They completely depend on the oil exports. These countries also are similar with regard to the cultural norms and, of course, with the political regimes. Both of these countries are harsh dictatorships. But if you compare Kuwait to Saudi Arabia, you'll see two major differences. First of all, if you look at the Saudi Arabia, you see that the capital city is located far, far away from the area of where the major population lives. So if people are unhappy with the policies, they actually need to cross half of the desert to get to the capital city. While in Kuwait, the capital of Kuwait is located right on the banks right on the bank of the ocean, and is surrounded by a huge capital with a lot of people. And although if you look at the formal indicators of the harshness of the dictatorship, both of them are both of these political regimes are really harsh. Nevertheless, Kuwait shows way better performance regarding the providing of the quality of the government services, corruption, the law enforcement, rule of law, and so on. So again, it's another important story, and where the ability to protest plays a crucial role. The Campanta, by the way, repeated this experiment using the American data. So what he was trying to do, that was already happening in the time when social scholars got really frustrated with challenges of doing the proper measures of the protest behavior of the protest events, and they started to look for different proxies. So in the first paper, Campanta basically didn't check the data on the population. He was just looking at the data of how far away, how isolated the capital city is from the rest of the country. And he assumed that the mechanism that makes Taiwan and Saudi Arabia, not the Taiwan, sorry, that makes Kuwait and Saudi Arabia different is due to the ability of people to mobilize and coordinate in the case of Kuwait, and huge costs associated with the fact that you live too far away from the government. That prevents you from making the Saudi Arabia government accountable to its population. There's another literature on the violence and repression, where the size of the protest plays a major role, and of course a set of papers by Erica Chenevet and the co-authors bring the major contribution to this topic. And again, the basic idea is very simple. If the protest is huge, then the risk of any individual protester to be repressed, tortured, and sent to jail should be smaller. Again, it is really hard to test this theory in case you don't have a proper measurement of the size of the protest. IR people, if they hear the story about civil wars and the start, especially the start of the civil wars, in the most of the models, the decision to start or to initiate this civil war crucially depend on the uncertainty about the potential supporters that each of the sides of the conflict can mobilize. Finally, we have some empirical evidence on the fact that the size of the crowd can bring the policy changes. So this example from McAdam and Sue basically shows I think it's the story about the Vietnam War, and in this paper they show that if the senators were if in the home state of a senator there was a huge protest event against the war in Vietnam, and the protest turnout was at least 10,000 participants. Then these people decided and voted to make the roll call vote, so to make it public, so to show their constituencies that they are actually accountable to them. In all of these theories, the accurate measure of protest is crucial. Excuse me. Okay. So now let's talk about the simplest story. 30 years ago, 40 years ago, we are somewhere in the US or any other country, and we would like to quantify a protest event. This is our goal. What tools would be used 30 years ago and 40 years ago to achieve this goal? Well, first of all, the important part is that from the academic perspective, there are two types of protests, and they are very different. The first one is extremely rare case. It's the case of the anticipated protest event, meaning that for some reason, we know that in 7 days, at the central market of the city, there will be a huge protest event. It means that we know when and where it happens, and we only need to face, some minor challenges. First of all, doing the survey always has a huge cost. You need to have a trained team, right? People who can, for example, run the survey, who knows how to properly sample people, because of course you cannot survey every protester if it's million people took to the street, right? Questions of the logistics also need to be solved. And of course, the question of the risk, because protest events most of the time are risky events, and you need to make sure, first of all, that your team does not face the risks, and also that the consequences of your study and the way you conduct the survey does not bring additional risks to the protesters. Actually, that's a lot, especially given the fact that even if we talk about the anticipated protest event, most of the time it's about, yes, we know that the protest will happen within the next 7 weeks. I almost know, I'm not aware of the cases where we actually know about some protest event that would happen at least, I don't know, 6 weeks in advance. And of course, if we are doing not the applied research, but the academic research, we have extra benefits here. First of all, if we want to run the survey or to do anything on the protest, even without running the survey. If we just want to count people, we need to get IRB approval. That usually takes time. Also, for academic purposes, it doesn't matter what things you try to measure if you do not have an interesting research question and if you didn't develop an interesting research design. So basically, even in the case when when we anticipate protest within the next few days, it's basically almost impossible to organize the survey due to all the challenges that you need to conduct within several days. Of course, with the unexpected protest events, everything is even worse. First of all, it's the most common case, right? But it has so many obstacles that some people still don't believe that people like me are trying to study protests nevertheless. So protest happened. How do we know about that? From the very beginning, if protest happened in past, we live in the world where we only can conduct a post-factum study. Right? What does it mean? It means that we can never meet actual people who actually take to the street in front of us, right? It brings a lot of additional obstacles and challenges. How can we get these participants? How can we find them? People took to the street. Everything was anonymous. Then they left this. Then they left the square. Where should we go to find them? Well, in some cases, people just try to scholars just try to do the general survey of the population, right? Let's go to this city of 10 million people and let's survey 3,000 randomly selected people. For the general purposes, if you would like to figure out, the overall mood, public opinion, and so on, 3,000 people is enough to make descriptive inferences properly. But if we talk about the protesters, it is very different, because even in the time of revolutionary events, a tiny fraction of people usually participate in a specific protest, right? So it is possible that while you run this survey of 3,000 people, there will be like 15 people who actually would agree to say that yes, we actually participated in that protest, right? And what can you do with these 15 people? That's one big problem. Plus, it is very expensive to run this kind of survey. So sociologists were trying to play around the sampling story, and they came up with the idea of snowball sampling. So the idea is that you actually don't need to do the general survey of the population of the city. Instead, you can try to you can go to the clubs where protesters usually relax and discuss politics. Get a couple of them, survey them, and then ask them to share the contacts of other protesters. And that basically helps you to create this network of the actual participants of the protest event that happened recently, right? On the one hand, it definitely has a plus. First of all, it's way less expensive than it used to be. Also, you can do a lot from the ethnographic perspective. So if you want to figure out what were the motivations, the reasons for people to participate in this protest, what were their priorities, and so on, you can use this qualitative evidence further. Unfortunately, if you're trying to make a proper descriptive inferences, any type of the statistical, you can't, because any conclusions based on the snowball sampling are compromised. And this is because any type of the descriptive inference requires the independence of the units during the sampling. And here with the snowball sampling, it is completely violated. Okay, now we outlined the standard set of the obstacles and the challenges a person who would want to quantify protest usually face. Let's talk about the two key methods that they used during the early days. And the simplest and the least expensive method is the assumption-based approximation. So if we are talking about a static protest, meaning that the protest happens only in a specific place, for example, the Central Square or DC Mall in Washington, right? So on the one hand, it is more or less easy for you, even without any specific tools, to figure out the protest site. Okay, where do people stay? What is the square that they cover? Second, you need an assumption about the density of the people at this square. Several approaches were developed here. When we talk about the American cases, usually for each person, American scholars consider to have at least 5 square feet. So if you have this assumption and you know the protest site, you can multiply 1 by 1 and get an estimate of how many people are actually located. We actually see at this figure, at this picture, right? Of course, we have a problem. And this problem is that this method requires the assumption of the constant density. So if you look at this picture, it looks like, yeah, probably this density is constant. But in 5 slides, I show you the data from my study, where I was unable to identify a single protest happened in 2017 during the wave of the Women's March elections against Donald Trump, where we actually observed a constant density of the protest. Even if it looks like that it's constant, in the vast majority of cases, the variation of the density within the protest site is huge, and it basically compromises any estimates we can get with this method. Method number 1, or method number 2, enumerators. So you bring the team of people, they have enumerators, they look at the person who enters the protest square, and they count, and then they bring them together and sum up the numbers they have on the enumerators, and that's how they get this number, right? So the problem here, again, it only works for the static protests. So if we're talking about the marches, this approach is not feasible at all. Second part of the story, apart from the requirement that the protest should be static, you also should have gates, right? There should be specific narrow places through which a protester can enter the protest event and leave the protest event. if it is an open square with no gates, then enumerators are useless, because people can come and leave and join the protest at any point in the protest, right? And also, what do you do with the protesters who come and go? How do you figure out that you don't double check them? Especially it's not only about one enumerator who controls specific part of the protest side, but also if you participated in any protest, you know that people actually walk in the protest side. They change the allocation. They stayed here. They talked to one group of people. Then they decided to move to another segment of the protest and talk to the other people, and so on. Again, no credible results can be obtained with this method. And of course, neither assumption-based approximation nor enumerators can work with the dynamic protest events. Meaning, if people go on march and then they start in one point and they finish in another point, there is no way these two methods can bring anything to you. Now, for quite a long time, the only standard in the protest literature for quantifying the protest behavior was the usage of the newspapers, right? So with the newspapers, of course, it is easy to conduct, especially cross-national and cross-regional studies. You collect the local newspapers, you extract the information about the protest events, and then you try somehow to get the data on the number of people who participated in this specific protest. And here we, of course, faces a lot of potential sorts of problems. First of all, the bias in the coverage, right? Who guarantees that a specific protest would be covered? Does it depend on the policy position and the political position of a specific media outlet? Does it depend on the size of the protest? Does it depend on the political agenda of the protesters? And many examples we have when respectful media outlets decided not to cover a lot of the protest events, even though the readers expected them to do that. So this is basically the issue of the bias in the coverage. But of course, there are many more biases, right? So where do the newspapers, where do the journalists get the numbers, right? How do they know how many people participated in this specific protest? Well, basically, you get these numbers, journalists get these numbers from three potential sources. First of all, organizers. Organizers are always ready to provide you with the numbers of the participants of the event they organized. We probably should think about the incentives of the organizers, right? And when we try to bring the new methods, we actually can see that in many cases organizers overestimate the overall protest turnout, and of course it is completely compatible with their incentives. They don't want to, stay in history as the people who organized a protest that was never attended by more than 10 people or 15 people, right? The second source is the police. And for the police perspective, especially if we're talking about the authoritarian settings, police has incentives to report underestimated numbers. Of course, I mean, both of them, organizers and the police, they still use heuristics to figure out the size of the protest, right? So even at this level, we have no idea how credible are these estimates. And in this, on the slide, you see a distribution of the estimates of the size of the protest events, of the protest turnout, in 80 Russian cities the protest that happened in 2011, when there was a huge electoral fraud, and Russians, for the first time in decades, decided that they understand that it was a fraud, and they are not ready to tolerate it. So there was a huge wave of the protest, and if you look at the distribution of the estimates of the size of the protest provided by the organizers and provided by the police, first of all, you can definitely see that these are two very different distributions. And these distributions actually describe the same event. Right, and we definitely see that this right tail. Oh, actually, yeah. I'm sorry, I forgot to put the label. So the red curve is the estimates provided by the police, and the blue curve is the estimates provided by the organizers. And of course, for the organizers, we see this right tail, and the distribution is skewed to the right, so they kind of would want to tell more and more people participated. And strangely, for the police, it sounded like the police had a command always to report that in the city the protest turnout always was slightly less than 1,000 people. Yeah, so it's I think it's logarithm. So actually the spike in the red distribution happens around like 900 people. And it is impossible to correct for these biases. I studied it nevertheless, but we should be able to. We should always consider these biases. Okay, so I have maybe a question to the audience. Imagine this situation. We have a wave of recent protests that happened. Cities in Taiwan or cities in the US. What we see that after this wave of the protest, in some of the cities, these protests were followed by the policy change. Doesn't matter. Let's talk about the public spendings on daycare for children, right? So you would want to estimate the impact of the size of the protest crowd on the chances for this policy to be changed. So basically, if you think about the data set that you would use to test this theory, you would have a policy status for each of the city, right? You know that in this city the policy was changed, and in another one it remained the same. Right. Next, you'll need to somehow reach the protest organizers, ask them, can you please provide us some rough estimates of how many people actually participated in the protest you organized? Then you regress policy change on the protest size and get the coefficient in your regression. And this coefficient is positive and statistically significant, suggesting that in the places with larger protest crowds, you should expect more chances of the policy change and more occurrences of the policy change. However, can we make any credible conclusions from this data? Well, of course, no. None of the alternative mechanisms are addressed in this in this setting. And what's most important, we need to consider incentives of the different actors when they do report the number of the protesters, right? So maybe in this case, what can happen is that the protest organizers in the cities that had the change in the policies started to think, well, probably this change happened because we were able to mobilize this huge crowd, right? So the logic can be reversed, and nevertheless we would observe the same statistical pattern, right? Again, another problem with the issue of the protest measure. Now I've talked a little bit about this phase when the scholars decided that the question of the protest size and the quantifying protest is on one hand extremely important, but on the other hand it is really hard to get proper estimates of that. So they decided, okay, guys, let's use some proxies. So in the two examples that I provided before from Campante, the examples, the proxies that they used was in the first example, it was the average distance of the capital city from the main populated areas of the country. The further away you are from the general population, the easier it is for you to conduct bad policies and avoid punishment, right? The second paper by Campante placed this framework in the context of the American cities. And what Campante showed in this second paper is that while it is really hard to measure the actual size of the protesters and actually catch the protest, what we can check, we can look whether the city has a relatively large square in front of the public administration building. And what they showed that if the city actually has this square in front of the major public administration building, assuming that because of that, it is easy for people to mobilize a huge crowd and to request something from the government. So in these cities, the quality of governments indicators were definitely higher than in the cities without such squares. Now, I also tried to use this the same logic when I was trying to figure out the impact of the protest on the size of the electoral fraud in Russia. And in my case, what I actually, instead of using the allocation of the population, I just use the terrain, the rough terrain around the cities.
Hello,
Carl, are you saying me something? Are you telling me something?
Hi, we have a question from Jessica, Professor Jessica Hansen de Fusco, and her question is: if you cannot trust the accuracy and reliability of specific numbers of protesters, can you then instead categorize protest by size categories, or to see if the categorical size is statistically significant on the likelihood of policy change?
Thank you, Dr. De Fusco. This is the great question, and actually, you basically anticipated partial evolution within this field. So what happened at some moment is that those people who decided that it is too challenging to get a proper estimates of the size of the protest, they decided, and those who actually didn't want to use the proxies because it the usage of proxies brings another set of challenges. So what they try to do, they've been trying to adapt the existing theories to the specific type of data that is actually really easy to collect. And so you've been talking about, just the categories of the protest size, like big versus medium versus small. They went further. They just said, okay, now in all the regressions, in all our models, instead of putting the estimates of the size of the crowd, we will just use the raw number of protests that happened within a specific time. So we will completely disregard the fact that one protest collected 1,000 people and another one collected 10 people. We will just count the occurrences of this protest. And in some cases, they were able to show interesting results. Again, I believe, of course, identifying a protest event is way more simple task than trying to measure other informative features of the protest. So yes, we had this line, and I wouldn't say that it became popular. What became popular is what I'm going to talk next, meaning bringing the big data and AI technologies in, and finally being able to provide something credible at the moment. So I will start with a very simple story that actually has nothing to do with AI and big data, but is definitely related to the overall technological progress. And this is the story of drones, right? Around 15 years ago, first drones with the high resolution cameras were introduced to the market. And these drones had a huge impact on both on the protest organization, because drones were used by the protesters, and also by the academics, because now academics could use this high resolution photos to get a better estimates of the protest participation. Now, again, the fact that you can get a high resolution bird view photo of the protest has nothing to do with machine learning, with any algorithms so far. You basically go back to this initial to the initial method of the assumption-based approximations, but now you actually don't need these assumptions, right? Because you can observe each person at this photo. You take into account the variation of the population density within the protest site automatically. So you can just count the numbers and get a pretty good approximation of how many people were there, right? Now, and of course, from this new source, you can add many extra layers. You can count it manually. You can think of optimal strategy to make all the required photos. You'll need to solve the question of how to mitigate the question of duplicates when you actually when you count the same person several times. And it is of course an issue where you cannot have this one huge picture, and you are forced to have multiple pictures with just the pieces of the protest sites, right? And here the machine learning helps a lot. All right, so that's one revolution that happened, and it's already improved our confidence of these studies. The second revolution happened, and this revolution is social media, because social media provided multiple new sources that could be used to somehow quantify protest behavior. Well, first of all, if we talk about the social media, in contrast to the traditional press and news reports, we shouldn't expect a lot of the biases and coverage, meaning people who participate, especially in the democratic settings, if a person decided to participate, she'll probably make a photo or will try to, post something on Twitter saying that I'm proudly participate in this protest. So when we talk about the question of how do we catch the protest, social media solves it for us way better than any other source, right? That's one part of the story. The second part of the story, social media provide different types of data that can be used differently for the for the task of the protest quantification. For example, well, we can use the first of all. The simplest thing is that just look at all the people who mentioned the protest event. For example, by putting tag Women's March in Chicago. So everyone who put the Women's March in Chicago in his on one of the tweets is considered to be a participant of the protest. Again, many potential issues with this one, but I'm trying to simplify as much as possible. So this is one source of the information from the social media. Second source of the information from the social media is the geolocation. If people, as you know, Twitter and other like Instagram and other platforms allowed you to put a geotag, right? And of course the geotag. And of course the geotag is way more credible source of information because it's not the opinion that a person shared. Maybe she wrote something that she participated in that, or she planned to participate in, but at some point decided not to go there. Right? There is no way we can check it. With the geotext, we know that maybe not this person, but her mobile phone definitely visited the protest square. Right? Finally, people on the social media make a lot of photos, and you can use the photos as visual information to estimate the protest size. Of course, there are a lot of questions again, like with any algorithms that try to make proper statistics of specific event based on multiple overlapping pieces of the data. By overlapping, I mean that several people can appear on the several photos of the same event, right? So the social media gave us at least 3 new channels to estimate the protest size. Yeah, and of course, yeah, if we have not the social media but just the regular CCTV. And especially if it's located in a good place, like you see here, the videos from that also can be easily used as the input for the regular convolutional neural network classifier that would identify. Well, in this example, they identify the faces, but you can identify people by many features. So, social media, drones, internet, photos, these are all new representatives of the big data world, the new age world, that gave us definitely better estimates of the methods to quantify the protest. I must say at this point, however, that still the question of the credibility of these estimates remains. If we talk about the Twitter data, there are a lot of potential biases here. Who are the people who decide to share the information? How do they differ from those who participated in the protest and decided not to share? What about the people who don't want to risk, but would put the geotag, or would put the mention that they will be with you, will be with protesters, right? How can we account for all of that? That's a big and open question. So to work with this question, me and my colleagues from UCLA try to employ newly available data on mobile phone locations in the US. And up until 2020, the market of the of the data on the location of the mobile phones was a pretty competitive and almost no regulated market, and anyone from the criminals to investigators could get this data and use it. So in this animation, you actually see the example of one of the providers of such data called SafeGraph, and the best example they decided to put on the main page of their website is actually an example of the Women's March happened in 2017 in February in DC. So basically, you see this individual pings. Where do people were during the protest? So what we decided to do with this data, we decided to use this individual level data about the mobile phones, and it's a huge data set. So in our case, we use the data of the 20% of the adult population of the US, and this sample is representative over all population. Overall adult population of the US. And our idea was, okay, guys, let's use the data on the mobile phones as the ground truth, because in contrast to the reports on Twitter, in contrast to the numbers provided by organizers, in contrast to the numbers that journalists report in the newspapers, that is something truly credible. We have all the reasons to believe that if the mobile phone of the person was at the protest square on the day of the protest, during the time of protest, it is highly likely that the owner of the mobile phone also was there. So we can use it as the kind of underlying ground truth data. And we can compare the estimates that we get of the protest size, that we get of the protest events that we get from the mobile phone data, and compare them to all the other sources available to us. Specifically, we've been thinking about the Women's March protest, happened mainly in 2017, and our approach was more or less simple in this paper. So what we decided to do, how did we use this data to estimate the size of the crowd in the specific place? So first of all, we got the list. Carl?
Hi, Anton. I know that you still have 6 or 7 slides. Can we wrap up maybe in sure. 5 to 8 minutes so we can reserve time for Q&A? Yeah.
Okay. I'm sorry for that. Okay. Yeah. So wrapping up. So the idea for that project was that we've been trying to use aggregated data to make sure that we don't use the personal data of people to get the rough estimates of the people who participated in each out of 400 protests that happened in 2017 in March. And for that, we use this idea of the geohashes, the small squares that you can use to split the territory of the city or any geographical territory. And then you could calculate amount of pings, unique pings from this area. And because you know the identifier of the device, you can basically suggest that if there is a spike in a specific, in this like very red square here, if there is the spike, you can consider this specific this specific geohash, this specific square as the place of the protest. Of course, we did a lot of different other robustness checks on the rest. But at the end of the day, we contrasted the numbers we get from the mobile data approach with the traditional and new approaches in for measuring social data. And surprisingly, the correlations among all of the measures are pretty good. Of course, they are best for the textual descriptions from Twitter, which is a little bit strange. But the correlation with the regular news reports, with the things we get from the images, they all are pretty good correlate. And and of course our main conclusion here is that while in most of the cases we cannot use this specific mobile phone data, this granular mobile phone data to estimate the size of the protest, we nevertheless have the evidence that the estimates that we get from the publicly available resources, like the news reports, like the social media and so on, they correlate pretty well with more reliable indicators that most of the time are not accessible to us. Okay, so actually, yeah, I wanted to. So, Carl, do I have like 4 minutes? I have 2 more stories to tell. But I can either don't cover any of them or can just slightly talk about one idea.
Sure, I think you have 5 or 6 more slides, right?
Okay.
I think we can finish in five or. Yeah.
Well, informatively, it's just 3 slides that I have.
Okay,
2
sure.
of them
Please
I
go
about
ahead.
the same idea. Okay. Okay.
Please go ahead. Yeah.
So one of the stories I've been working on with this data is this question of going even further with the accuracy of the going even further with the accuracy of the estimates. And one of the problems if we have these things like mobile phone data, one of the problems is, on the one hand, it is easy for us to locate the place where is the spike of the pings from the mobile phone. So we know people actually gathered here. There's, of course, another problem that we would want to distinguish, for example, sport events from the political events. And we need an algorithm to identify specifically a protest event, and we worked on that. But the other problem is that imagine that the protest happens in the center of Washington, in DC Mall. Among the people who protest, there are many regular tourists who happen to be here on the same day. And their mobile phones send the same signal, and we cannot distinguish between them, right? And also, there are many people who just work around DC Mall, and they can appear in our data set just randomly. So to mitigate this problem, I propose the solution that is based on one assumption that is completely justifiable. This assumption is, if people participate in a collective action, especially if we talk about things like marching, then they actually usually follow the same trajectory, right? They start in one place and they finish in another place. This trajectory should not always be completely identical, but they should be significant overlaps. So what I'm trying to do in the paper that I'm referring, I'm trying to use just a regular convolutional neural network to try to classify the trajectories of the people who've been at the DC Mall on the day of the protest. And it turns out that it's pretty you have this gray zone of people who could be protesters, could not be the protesters. And if you just figuring out how close their movement to the average trajectory of the protesters, of the identified protesters, then you can easily figure out who were the protesters and who were not the protesters within this gray zone. Okay, so that's one thing, and I want to finish with the idea that the AI, and especially of course, convolutional neural networks, even the simplest one, they give us way more food to think about the protest and work with it. So, for example, using the photos, you can not only estimate the size of the crowd, but the overall mood of the people who participated. Are they angry? Are they scared? Do we see the violence? Is it a violent protest? And so on. Now, that's one story. And another interesting story within the same logic is the question of we can use other big data sources to test other interesting features of the protest. So in this paper that we're working with with one of my graduate students, what we're trying to do, we're trying to figure out whether some of the protest events or the protest movements that are considered as the single protest movement is actually misclassified. And we deal with multiple protests with very different political agendas that by mistake is considered the protest under the same umbrella. And the idea that we exploit in this paper is that we look at the protest in India in 2018, and what we do, we look at the search queries that are correlated with the search regarding the protest that happened in 2019, based on the regional allocation of people. And what we actually see that while a lot of people look for the information about the specific protest, the other search queries that they do on the same day actually provides us with the conclusion that people think very differently and perceive these protest events very differently. For some in this case of 2019 India, for some of the regions, people are thinking about the protest as like the immigrant issue. Others were thinking about the student issue, and the third group was thinking about the human rights issue. And we have a formal procedure to identify and distinguish all these groups and their agendas. Okay, let me wrap up at the moment, and it's basically most of the things I wanted to discuss, and I am happy to listen your questions.
Yeah, I think, let me see. Let me I come here to moderate, and if any questions from the Taiwan side and also from the US side, and you can either type your question if you're too shy, or you can just speak up, and we will be we'll be glad to actually to entertain questions like a one-on-one. You can just speak up and speak up the question. Peter, do you have some on your side first, or I can give one, and because I can't wait to ask this question to warm up. But anyways, I wait for the Taiwan side first.
Thank you for giving me the privilege to start. So Anton, I just wanted you to know, so I'm still wearing mask because I'm in the classroom right here, and some of our students we're in the same classroom. So that's when I'm wearing mask. We still observe this code here in Taiwan. And here are a couple of questions I got here. One of it is that back to the theory part, or from social science part or political science part, even we can measure the size more accurately from this time forward. All right, with AI or big data, all those methods. But how do we explain? That's the question we want to ask. How do we explain government's response to protests in the past, when governments did not have credible estimates of the size? So that's what we were asking, right? If the protest can affect government's response, and we try to measure that. Well, what would you say? We want to regress that to government's response or chances of policy change. But well, for the last part of your presentation, probably you give us some descriptive um, picture, like the Hindu case. So how they gather and where is the spike of the people who gathered, but that's more of description, the descriptive data, but in terms of the explanatory side of the story, and how do you can you share a little bit about your research? Then how did you do with that? That's the first question, and then here another question is about. All right, the dynamic part. With more reliable methods, it's kind of can it overcome the problem of measuring a dynamic protest? See, we have a march, so people come and go, and then what matters? Is the maximum number that matters, or how long it lasts, or other features that how much, how big is the area that's covered? So what are the features that you count as more important? Yeah, I have these two questions that, all right, Carl?
Yeah, that's great. Anton, why don't you go ahead to respond to those questions?
Can you give me 5 seconds? I want to
sure
put down one of the answers because I will forget about it. Just 5 seconds.
Yeah, in the meantime, and I will invite any questions from the USI or any students, any colleagues or faculty members that would like to ask a question, or you can type it up, or you can wait till Dr. Sobolev is ready. In the meantime, I can type up the question for you, and so I can collect everything so it can be more easier for Dr. Sobolev to address the question. Type it up. Go ahead.
Absolutely.
Go ahead.
Okay, so brilliant questions. So I will start with the first one because maybe I like to confuse people, and maybe I confuse here as well. So what basically I was trying to say. Your question is, okay, we have this story. If the government know how much people were in front of the public administration building, they use this information to decide what should be appropriate response. Should we provide them with the policy concessions, or should we just send half of them to the prison? Right, but I mean, in the two examples that I've provided, actually both of the cases were slightly different. So in the one case, when we were talking about Campanta's idea of like how far away the public administration building or the capital city, meaning the government, how far away it is located from the majority of the population, right? So in Campanta's theory, the reason that the Taiwanese, Kuwait government of the Kuwait didn't practice better policies, tried to fight the corruption and achieved better results for the quality of the government administration. According to the Campanta's model, it was not due to the observed size of the protest. It was due to the credibility of the threat of a physical replacement. So Campanta says that maybe in Kuwait there were 0 cases of the protest events in the last 50 years at all. Nevertheless, the fact that in case something happened, it is very easy for people to take to the street and create a huge crowd. That is the factor that motivates government of Kuwait to behave responsibly, not to steal too much money, not to kill too much people, and so on. So, and I will go to the initial question. I just want to clarify these two stories that I told. And in the case of the American protest, when the senators decided to make things more publicly, it was, I would say that it is a very specific case, and it's not the case where this about whether we need to introduce repression against people. It's just, okay, I felt that there is some kind of slight control of people, so I just want to make sure that I play the fair game, and I don't think that they actually I mean, from this study, we cannot make a conclusion that the fact that these senators decided to behave in a more public manner, it was actually due to the size of the protest. Again, that is the key problem. We have so many studies that try to test several of these theories, and I would say that most of them are compromised. That's why, while we have a lot of studies, a lot of attempts, our conventional knowledge in this field is very limited. Yes, millions of papers, and the vast majority of the experts don't believe in them. So that's I think and of course, in the real world, the response of the government is the government use extremely tough estimates, like I've described to Professor De Fusco. It's like 0 or 1. Do we see the people in front of the building? We should react to that. We don't see. We probably shouldn't react. That's it. Okay. Now, talking about the factors of the success of the protest. So I think it's a very big literature. We have several schools of thought who think about systematic, non-systematic, individual, any other types of the communicational factors that would affect the success of the protest. And I myself have like 3 papers that specifically look at the question of the composition of the protest and its success, the allocation of the protest people and its success. And we have no confident results anywhere at that point. So again, I can refer to the set of books and papers by Erica Chernovit from Harvard and her team, and basically, they have a claim that if protesters decide to follow non-violent strategies of the public resistance, in this case, the protest movement has significantly higher chances to succeed. That is the claim they make, and they have other claims in this book. By the way, this protest data set is available. 3 versions of this data set are publicly available. You can go and check all of them. Now the problem is that I cannot trust these results because while I understand the basics of the probability theory, I do not understand how using the probability formulas we can make causal claims, right? And moreover, in all of these papers that, again, I admire the effort that Chernovit's team is doing by compiling this data set with a lot of important information. But definitely one part of the story is that in all of this data set, they don't have a column that would refer to the size of the specific protest event.
All right, thank you. Yeah, thank you. Carl, you have more
questions?
Yeah,
I have a question here related to that. And I have also my questions too. So let me read out the questions from Hannah Sheen. And is it important to look at the severity of protests? And some protests might be more violent than others. and it will lead to changes policy much more easily than the number of people in protest. I think the size versus the severity. And let me add on to this question. I think you addressed this somewhat and in your previous answers, but I want to add on to this question. I want to talk about the Hong Kong protest too. And in 2019, I think you may have studied this already. I think that is something particularly interesting and raising some questions, some new questions. The number one thing is how to measure the size. And I don't know whether these scholars or journalists copy your method. And in 2019, actually, they rely more on the social media traffic, and because they come up with derive like a certain connection or correlation. For example, they get to collect the data for the previous protest organized by a coalition, which is the main organizer for the protest, or multiple organizers. Then they measure the volume of traffic in the main social media, and that is one similar to the one in Taiwan, like a D card, or it's called a Lead Hong Kong, and similar to D card or similar to PTT, and like a bulletin board type, and plus the Facebook data. They come up with, for example, the volume change in traffic change. So then they can come up with another multiply effect that is actually quite accurate. And for example, and the first protest is driving 500,000, then the traffic jump big time at the government response, like then 2 times, and actually then that predicted the next protest to be 1 million. Then do the same thing for the 2 million protest, and that is similar to yours. And this is something interesting. But one thing that I want to bring to your response is how much this could be actually thinking, bringing this to what is saying that the message becomes the messenger. So these data, of course, if they can calculate it, and the government is actually doubling the effort in collecting this, and try ways like, of course, they can have access to the mobile phone data, to the actual traffic, like a subway data. Then they double the effort, or triple the efforts to do that identification, and take the videos and data analysis later, and then use that for later arrest and later prosecution. So my question is, yeah, indeed, in some regime, in some protection, like you have some democratic system protection mechanism, but the government could actually do it the other way, to use this kind of data, to use this kind of approaches to exert tighter control on the population. And in fact, there are multiple things that are coming up with that protest 2019. It could be something really textbook to study, like the government used the data to develop new technologies and new algorithms. So these new algorithms are being exported to other countries too. And now it could be hard to really test that, because of the COVID, and COVID is a good reason to stop people from taking to the street. But this is something I think you may factor in, because it's a dynamic situation, and then the protest and the policy change. Then, but actually, you can see that the protest size, or protest severity, or the violence, and could be the driver for the government, particularly draconian governments, authoritarian governments, to develop new technology to exercise tighter control, and exercise more even more draconian control over the population.
There's so much.
Yeah.
There is so much questions. So many questions. Carol. So I will try to address several things
Yeah.
that I probably understood. I am okay. So this idea with the traffic data, I mean, it looks interesting, and I am not surprised that this approach will provide a robust and predictable results for each case, and probably will work well. The requirement of this approach, however, is still the fact that we need a mapping of the traffic data with an actual person. So, if, for example,
not necessarily. No, it doesn't take the geocode or geographical data of the mobile phone.
No. I'm not talking about that. I'm talking about the fact that, for example, we need to know that if person takes to the street, what is the average to protest? What is the average amount of traffic he or she consumes within an hour? If we know, this data, then we need this proportion. If we know this proportion, then of course we can always make predictions out of the overall traffic, and we don't need to care about any privacy because you just consider the overall volume. Of course,
the volume is the key, because a lot of protesters are using VPN, so they are aware that the government will track them down. They're tracking them to and then maybe 6 months later, you were in that area, you were in the protest, and how do you explain that? And so a lot of them are actually using VPN now. I think most of them, and they're aware of the consequences, and it's very common for them to do basic protection, even though the protection may not be bulletproof, because a lot of VPN companies are owned by the Chinese companies.
Absolutely. So I want to address two more stories that you're So the first story is it also goes back to the question of the success of the protest. So of course, we are in academia. We care about the protest numbers because we want to understand how the world works, how to properly test our theories, and how feel good about yourself. I came up with this solution, and now the world will remember me as the person who solved this problem. And that's why we care about, like, we are basically behave as the medical doctors, right? Our main problem is that we cannot afford to bring any, even minimal, but even potential harm to people whose information we use. On the other side, there are other groups that are not academics. For example, politicians or authoritarian politicians who care a little next to nothing about the problems of the violation of your rights, bringing the damage to you, and so on. And of course, these people are also extremely interested in getting and provide and having the technologies that would also help them to, for example, to figure out the size of the protest. But I want to say that first of all, this, if you will consider, for example, government of China, their main challenge, their main thing that they hunt is not how to get the overall estimate of the size of the protest. What they want to be able to do, they want to be able to identify the specific protesters, right? Because if they are able to identify specific protesters, instead of spending the huge amount of money on the control of the political protest, on the what's so-called non-targeted repression, when you beat everyone who participated, right? It is costly, and you have a risk of the backfiring, because people can make a video how the policemen beat like regular non-violent activists. right? So the goal for any authoritarian government in the 2022 with all its technologies that we have is bringing all the machine learning, all the new technologies to the goal of identifying the activists and the protest leaders and organizers, right? If you can target just them, it's simple for you, right? You can if you target a specific person, you don't need to do it publicly, right? It is less harder to you don't need to justify anything, and so on. And that's why I refer to my favorite AGPS paper from 2020 by Susu. He was at Princeton at the moment, and not sure where is he now. But in this paper, he shows that Chinese provinces were trying to introduce the systematic digital surveillance at different stages. And he shows that after a digital surveillance system is introduced in a specific city, this city faces less protest events and also significant cut in public spendings, pensions, support for the poor people, and so on. Why do you think it works? Well, because if there is no risk that people will backfire the fact that they didn't receive a pension, why would you care about their pension? Yeah, you're politically safe. So yeah, and that's why governments definitely interested in this slightly different story, but nevertheless, it's very close. And of course, the asymmetry comes from the fact that we do care about people and they don't. Yeah. And if I might add to the last part, the last part here. So you've been talking about the fact that you can authoritarian governments can actually have an advantage in providing different services, because for them there are less restrictions for example, for the tracking the people, doing the digital surveillance, analyzing their traffic, and so on. And what I would want to say, so on the one hand, they do all of that for the political reasons. They want to control people to prevent them from taking to the street. On the other hand, this data can be commercialized. It can be used for training more sophisticated algorithms and so on. And the good news is that this paper is already written. David Yatman and colleagues wrote the paper on how Chinese government cooperate with the AI companies, provide them with all this data that's collected with the CCTV cameras by the police stations and so on. This data is used to train more sophisticated models. And these companies became, using the data provided by the Chinese government, become more and more competitive on the international market for the high-tech technologies.
Yeah. All right. And my clock here is reading 10:58. It's a little bit late. I do still have lots of questions. I think this is a very interesting presentation. Still have a lot of things to learn, but I do like to give the last chance for any questions from Taiwan or the USI. Anyone? Maybe we can still accommodate one or two more questions. Anyone from Taiwan?
Yeah, not for now, but in a way, this is a very interesting topics, and then just keep us thinking more about the, because you mentioned about Chinese government and then how they use AI, machine learning, and as a tool to use it as a social control tool. So it's quite different from what we've been talking about, how the protests can, affect the governance or about the accountability. It's quite a, kind of opposite story of using this new technology. So, we can think of more and discuss more about that, but I don't think that we have enough time to deep, go deeper in this issue. I'm hoping that maybe next time that we can still have another opportunity and then to exchange and talk about this, right? It's 12 o'clock. I'm not sure, Carl, do you have any other students or other questions from your side?
Let me check. I don't think so. That we have. I think this is a lot
I have the
of.
final.
Sure.
I have the final comment. If what I just wanted to
Please,
say that
please.
in one of my classes, I have a special week on like how the authoritarian governments use multiple. First of all, how they were afraid of all of these new technologies due to the Arab Spring stories and so on, and then they gradually figured out that actually they can use the same technologies against the opposition, against the local people, to keep this population in iron gloves, so we have this special week where we consider different digital strategies, mostly using the example of the Chinese Communist Party, and we'll be happy to invite you to this class when it will take place, and maybe organizing a video translation and communication if your students are interested in this topic.
Thank you. Yeah, great. That'd be great.
Great.
Thank you.
Yeah, allow me to, if you have that ready, I can disseminate to the Taiwan side and invite our other students at the colloquium or our guests to come. All right, I think I will wrap up here. And thank you for, particularly thank you for Dr. Sobolev and for this really exciting and really informative presentation. I believe that I learned a lot myself, and I hope you can find this particularly inspirational and inspiring, and also getting a lot of new ideas and getting new technologies. And allow me to quickly introduce next week we are going to have another scholar and to give a topic. And you see my screen now, and Dr. Matthew Lebo, and he is currently the chair of the University of Western Ontario. He's a time series expert. He will talk about beyond unit root and drawing inferences about long-run relationship given uncertain and univariate dynamics. And Dr. Lebo is has published quite a few papers in political analysis and HAPS. This will be a seminar you cannot miss, because it's a really good presentation by Dr. Lebo, and I know him in person because he's also a student of Dr. Harold Clark, our Dr. Harold Clark. So that will be someone. Okay, let me see if I can get back to this. Someone, can you still hear me? And all of a sudden it becomes. Okay.
Yes, we can hear you. But
you still hear me, right? But somehow, and let me see if I can do it from here. And okay, now, okay, it's back. My Teams is getting slow. Okay, I think I will stop here, and I look forward to seeing you again next week and same time. And Peter, do you have any concluding remarks?
Well, just thank you, Dr. Sobolev and Dr. Ho and all the audience today. And thank you for all coming back, coming today. And then we expect to see you next week at the same time. Thank you again. Thank you.
All right.
Yeah.
All right. Thank you all.
Thank you, everyone. I closely followed the colloquium, and actually that's why I decided to prepare a less technical presentation, because I mean your students already know well the specifics of the architecture of convolutional neural networks. So I decided that it's probably would be more interesting to talk about more substantive questions in addition to technical questions that I believe your students are very well aware of.
Yes, thank you for considering that,
right.
and we're also benefit a lot from your presentation. Thank you.
But I next time if you decide to invite me, I can make a like very sophisticated, technically sophisticated presentation that no one will definitely understand.
Yeah. but no need to do
I
that.
look forward to that. I look forward to that. Yeah. All right. Okay. Good.
Thank you,
Good.
everyone.
Good.
Pleasure being
All right.
here.
Good.
All right.
Thank you.
I think.
Yeah, thank you. Yeah, Carl.
Thank you again, Anton. I know you stay in office. All right, then I will stop
I
here.
probably need to go. I need to go home at the moment. Yeah.
Mhm.
Okay, it's quite late.
Bye.
All
Yeah,
right.
thank you for
Thank
staying
you,
up
everyone.
late.
Bye.
Yeah, yeah. See you next time.
Thank you. Bye, Anton. Yeah.
Yeah.
All
Bye,
right.
Carl.
I think. Good. Good.